Hi, everyone. It's great to be here today to get to talk about ISP's restoration program and the work that we've been doing to enhance San Francisco Bay shorelines. We hope that by sharing some of our work, it can help guide living shorelines projects that are working in the spaces that we're working in. So ideally, living shorelines projects protect and enhance the full gradient of habitats from the subtidal up to the uplands, like Tobias was talking about, basically all the lands where tides can touch. Um, with the ISP, the lowest that we've really been working is the mudflats. So one of our goals is to restore mudflats. Tobias talked about how mudflats are critically important migratory stopover habitat along the Pacific Flyway for shorebirds and waterfowl, and uncontrolled hybrid Spartina was threatening those mudflat habitats. In addition, our other main goal is, of course, to protect our native Pacific cordgrass from extinction. So I'm going to be talking about habitat enhancements by marsh zone. So tidal marsh from the low to the high marsh, and then also looking at marsh upland transition zones, the space between the tidal marsh and the upland, so the slopes. I'll go into a little bit about how we select our sites and look at some planting designs, and then a few examples of before and after habitat enhancements at our sites, and some key lessons learned and recommendations. Next slide. So native Pacific cordgrass. Tobias talked about this, but I just want to reiterate, this is why ISB exists. Our aim is to protect this species and maintain functional native wetlands. Once again, Pacific cordgrass is our only native Spartina species in the estuary, and it's really, really widespread because the Invasive Spartina project exists. Currently, greater than 99% of the cordgrass that we have in the estuary is our native, and sometimes we forget to say that. Like, if you go out to a marsh, what you're going to see is the native. And that's because ISP continues to exist and we continue to do our work. So next slide. Oh, no, I'm sorry, not next slide, but yeah, next. There we go. So you saw this before in the zonation diagram, that narrow elevational range that the native grows in. We like to say it stays in its lane, it plays well with others. And next, in contrast, the hybrid Spartina grows in this much wider elevational range, so it can grow out across mudflats and up into the high marsh, threatening any native tidal marsh restoration project. So hybrid Spartina is usually the first one to colonize if it's nearby, and therefore it created novel habitat where there wasn't any habitat cover before. So picture a mudflat, and then you have vegetation, or a new restoration site, and then you have hybrid Spartina. Next slide. So ISP's restoration program started to support the inventory and treatment of invasive Spartina. We've been working for 14 years, and our focus is on the critical components of Ridgway's rail habitat. So providing cover from predators for foraging birds, for nesting birds, and then also for high tide refuge, basically looking at the whole life cycle of the bird. And our focus also is on rapid habitat enhancement, both to provide habitat cover quickly where removal of invasive Spartina has resulted in habitat loss, but also looking at these, young restoration sites and other sites that are lacking cover. We know that mature marshes have great vegetation, which can help trap sediment and slow erosion and possibly help our marshes keep pace with sea level rise, combating climate change. So rapid habitat enhancement to promote marsh resiliency in the future. Next slide. So our program has worked to date at 40 plus sites, and you can see those in the map on the left, really primarily in the Central and South Bay, and we've put in over 600,000 plantings to date. And in the low marsh, that is Pacific cordgrass. And in the mid to high marsh, it's marsh gum plant along marsh plain channels, along the edges primarily. And then also we've worked on two different types of high tide refuge within existing marshes. So I'm going to be talking about the marsh upland transition zone, the slope between the tidal marsh and the uplands, where we've focused on planting rhizonomous perennial plants. And then Zachary from H.D. Harvey & Associates is going to be talking about our collaboration with them to construct 82 high tide refuge islands at 16 of our sites around the bay. Next slide. So a little bit about how we select our sites. Once again, our goal is functional native habitat for California ridgway's rail and other wildlife. And our focus is on the critical components of rail habitat. So I've included these two photos of what we think of as high quality rail habitat just on the upper left. And in the very left-hand photo, you can see, the mud flats coming up to the marsh edge, and that dark green band that you see is the native cordgrass. That's providing really nice foraging habitat for rails. And then the sinuous marsh plain channels that you see extending up from that, the rails use those for foraging. And then the dark green plant that you can see along the edges of the channels is the marsh gum plant, which provides that kind of taller habitat cover that they need for roosting and nesting. And the right-hand photo at the top is showing kind of a zoomed-in version of one of those channels. So you can really see cordgrass down in the channel bottom, providing cover while they're foraging. And then the marsh gum plant is the yellow flowering plant on the sides that's providing that more heterogeneous, taller cover along the channel edge. And so our focus has been on sites where we've seen impacts from the removal of invasive Spartina that results in habitat loss. As well, we're looking at older restoration sites to kind of assess progress, and some of them, seem to be lacking habitat cover. They're not moving along in that trajectory towards having mature marsh vegetation that we'd like to see. So in the lower row on the left, once again, this is an example, zoomed in version of high quality rail habitat. And you can see the native cordgrass growing down in the channel bottom, providing that foraging cover. And then on the channel edge, the darker green with the yellow flowers, the marsh gum plant, providing that taller vegetation that rails like. And in the middle, this is showing a restoration site, which has passively revegetated completely, but the only species that came in was perennial pickleweed. So we're coming back into these sites because our focus is on rapid enhancement and planting, in this particular case of this one, marsh gum plant along that marsh channel edge, very densely planted plots that then we can plant a bunch of these as new nodes of habitat throughout the site. That is what rails like. And then the lower right-hand photo is showing a marsh upland transition zone. And this is typically what we see at our sites with these existing habitat features, is it's primarily vegetated by annual weeds. So we want to come back in and enhance these and create a more mosaic, a more diverse species structure, habitat cover for rails and for other wildlife, rather than seeing these annual weeds that are basically dead throughout the winter. So year-round habitat cover. Next slide. Planting designs. So once again, our goal is really rapid habitat enhancement. And so the designs we use focus on planting really densely, typically single species clusters of tall and or spreading perennial species. So in the low marsh, that's Pacific cordgrass. And in the mid to high marsh, and I talked about this, these kind of dense plots of marsh gum plant that we can plop around sites along channels to provide nodes of habitat, of that taller habitat cover. And then in that transition zone, we're focusing on rhizonomous perennials that are hardy, salt-tolerant natives. And the idea there with the rhizonomous plants also is that they can really persist underground in dry years, and then in wet years take advantage of that and really expand and cover more of your site. And also using rhizonomous species can help with, because they can grow really densely, can help with outcompeting some of the weed species that you have in the transition zones, the existing transition zones. Next slide. So here's an example of before and after habitat enhancement using Pacific cordgrass at sites. So this 3 sites I'm highlighting here are restoration sites, and you can see in the before photos, they're mostly open mud flat, essentially, because they're early in their restoration. And so both, rapid enhancement to provide that habitat cover quickly for wildlife, but also rapidly enhancing to kind of push these restoration sites further along in their trajectory towards having mature marsh vegetation, which can help them, trap sediment, slow down erosion, and help keep pace with sea level rise. And I've included the photo up on the upper right to show you, this is like one of our success stories. This is the original introduction site for the East Coast Spartina alterniflora that was introduced near here in a restoration project. And we've successfully controlled the hybrid Spartina out of this site and been able to come back in and plant with the native cordgrass. And it is now spread, and you can see we're really getting that narrow but continuous band of native cordgrass that we want to see at the site. It's a really great success story for us. Next slide. Here's another example I wanted to highlight. So Eden Landing Ecological Reserve is part of the South Bay Salt Pond Project. And this is a complex of a number of tidal marsh restoration projects. And the main problem here was that there's no local source for Pacific cordgrass anywhere near here. So in order to really jumpstart the marsh restoration process, we came in and planted extensively at this site and a few others with the idea that these propagules could then move around through the whole marsh complex and really start to move these restoration sites into becoming marshes. And so you can see the unvegetated mudflat in 2011 and 3 locations where we've planted cordgrass and it's become established and it's spread significantly. And unfortunately, I don't have a more recent aerial photo, but down in the lower left, you can see in 2019 that the vegetation has already expanded significantly. And if I had one from 2025, it would be much greater now. And the really great success with this is the Ridgeways rails have found this site. So in 2024, we had 22 birds here detected during our rail surveys. And we don't have the results from our 2025 ones yet, but it looks like we're on target to be the same and or maybe more birds. So a really great success story for the rails. And that they're going to be moving around in this complex too. So yay, rails. Okay, next slide. Okay, taking a step back, I've just talked a lot about planting cordgrass, and I want to say that ISP only does this with really careful planning and consideration. And so I know this is a no-brainer, but obviously, if you're thinking about your plant palette for your projects, do not think about introducing the East Coast native to San Francisco Bay. Also, please refrain from transplanting cordgrass from near your site into your site. There is a risk that there could be hybrid there. Always, when thinking about adding cordgrass to your palette, contact ISP, talk to us. Invasive Spartina is still in our estuary and there's a real risk to project plantings. So consult with ISP early and always. Next slide. Going back into before and after habitat enhancement using marsh gum plant, I'm showing 3 different sites here that are all restoration sites that have really passively revegetated well, but with only one species, the perennial pickleweed. So you're not seeing that heterogeneous habitat cover that rails really like. So we've come back in here and planted the gum plant in nodes around the sites, and you can see we're starting to get that habitat cover. Next slide. I'm not going to go into details on this other than to say there's a lot of folks working in the marsh upland transition zone and doing a lot of great work on how to design, construct, and manage transition zones. Our focus is on existing T-zones, and so we're looking at annual weeds and how to deal with them and using the concepts of competitive planting. Next slide. This is a slide showing our planting process, just to point out that it's a year-round process from, contracting with the nursery a year before with the plants that we want to put in, doing site prep, planting in the wintertime when you take advantage of the natural rainfall. Right now, we're in our busy season for weeding. They say gardening is 90% weeding. Well, that's true when you're trying to garden in the wildlands too. And then, of course, other things you might need to consider during dry years, doing a lot of watering to get your plants established, and then monitoring to do feedback into your future projects. Next slide. This slide is in just to talk about constraints associated with working near tidal marsh habitat. There's a lot of endangered species, salt marsh harvest mouse, ridgeways rails. We have trained biologists monitor all of our activities. Timing constraints, we can only plant and weed outside rail breeding season. Also access can be really difficult during the winter when you want to be planting and working with these sites. So things to think about. Next slide. This slide is showing before and after transition zone habitat enhancement. So we've had a lot of great success so far, and weeding has been really key for us. Next slide. So lessons learned and recommendations. Invasive species management should always be an integral part of projects from beginning to end. Caution, please consult with ISP before considering planting cordgrass in your projects. We focus on rapid enhancement, plant high density single species plots. When thinking about marsh upland transition zones, think competitive planting. And then our main message today is rapid enhancement now to promote tidal marsh resiliency in the future. Next slide. So thanks to all our partners and to our small and mighty crew at ISP.